All right, thank you very much. So we started a few servers to test the performance when it comes to prompt processing, and this talk will cover that. There's not much time to do a proper intro, but SpareCourse is trying to bring clarity to cloud server options. Very happy to share more, like technical details and some fun stories about the vendors at the after party. So please say hello if you are there. But a quick intro, we are providing open source tools so that you can build an inventory of cloud servers at the supported vendors. It's not only a wrapper around the vendor APIs and listing the SKUs, but we actually start all the servers, run hardware inspection tools and various benchmarks, and we make that publicly available in databases, APIs. We manage the related infrastructure so that you do not have to burn a couple tens of thousands of dollars to run the very same benchmarks. And one of those benchmarks is actually the LLM Inference speed that I will quickly show you. High-level stats about what we cover: well over 2,000 servers being tested, and the related prices warehoused every 5 minutes. The hyperscalers, a few European vendors, and so on. Everything is run in public using GitHub Actions, so you can see all the Pulumi template outputs, all the benchmark results, and everything in our GitHub repos. Please look that up if you're interested. But for human inspection, it's much easier to go to sparecourse.com, and we have a web app there. You can see all the servers, you can sort, filter, and so on, look at the prices. Once you click on one of those, you get the details about the servers, prices, about spot, on-demand, and so on. Bunch of benchmarks like memory bandwidth, OpenSSL, hash functions, ciphers, compression algos. We also run test suites like PassMark, GeekBench, many others. We also look how well an application can scale to multiple vCPUs, like looking at the effects of hyperthreading and so on. We publish some related visualizations and some application-specific benchmarks as well, like web serving or databases. You can also compare these servers, like any combination of these 2,400-ish with tables, with tons of details. You can also generate charts about all the benchmarks that we are running. There's API endpoints that you can use. Those are public, and also SDKs where you can get the info in a programmatic way. And we are also making some SQLite files available, so you can just embed it in your application and use the data that we have collected over the past year or so. This is on GitHub. Check out if you're interested, but now let's focus on the LLM stuff. So we started with a multi-arch container image, which includes builds for ARM and x86, including Llama CPP. And it's built for different CPU families, and we also included a CUDA build. And this is the compulsory AI-generated image that I generated yesterday with the prompt of a transparent background. Like, nice job with that. And I just wanted to show that we have CUDA builds. I have no idea what's going on there, but decided to include here because I found it hilarious. Okay, so regarding what we are doing as part of the LLM benchmarks, we are looking at prompt processing speed and text generation speed using various token lengths. As you can see here, we picked 6 models, from smaller ones like starting at 100 million parameters up to 70 billion parameters. And of course, we set a threshold because we didn't want to spend more than 10K on this. Looking at the number of servers already evaluated, it's a bit over 2,000 as per yesterday night. So I managed to keep to the promise of the title of the talk. And here you can see this is actually an embedded iframe from our homepage, where you can see the prompt processing speed of a given server. Well, this is at Google. If you click on this, you go to your homepage and you can check all the other things. I will skip the live demo, so just showing a few other screenshots. If you look at our server listing, you can select any benchmark, like I picked one of the LLM Inference speed ones. You can order all the servers by that, and not only by the raw benchmark score, but we also provide a cost efficiency index, which is dividing the benchmark score by the spot instance prices, so that you can pick the one where it's the cheapest to run LLMs. You can also compare these stuffs. You get these tables, and you can also generate different plots for the results. Okay, no time for interactive Q&A, but I know what's on your mind, and I didn't want to let you go without answering those. So it can cost quite a lot to spin up all those 2,000 servers, especially if things go a bit crazy at Azure. Some instances not terminating in time. So it was well over what I thought, but fortunately didn't have to spend too much because of credits. There are limitations, of course, and when it comes to best server for LLM, it depends like what you are looking for. We have many benchmarks for LLM, so look up what you are interested in and hopefully you can find the results. I'm in a good company, as you can see here, and Attila is sitting somewhere here if you have technical questions, and I know it's well over time, so I'm stopping, but before that, please visit sparecourse.com and let us know what you think. Thank you.